Okay, everyone. I'm going to start by telling you where FHIR fits into the overall picture and answering some of the burning questions from yesterday. And then Diego's going to talk about where we are around the world with FHIR. Given that we're a bit short on time, I'll skip a few slides. Oh, this has happened again. Lovely. Right. So when I think about FHIR, FHIR for me is two different things. It's a community that's goal is to make it easier to exchange healthcare information. We have open participation and we're led by HL7, which means we're deeply connected around the world. And then that community produces an open standard that describes how to exchange healthcare information that is open and web-based and has continuity with existing healthcare standards. And actually, from where I sit, the community is more important than the technical standard, although lots of people focus on the technical standard. Now, it's really important to understand that FHIR is an exchange standard. It's the set of rules for how data is exchanged. It's not a product. We don't sell anything. It's not a software. It's just the static rules for how data is exchanged between two applications. So they can both implement FHIR and then they can talk to each other without too much additional assistance. So any healthcare application can use FHIR. For instance, DHIS2 can get and share data with other applications using FHIR. You could use other standards as well, but they could use FHIR. And so in that sense, FHIR is for all applications if they want to share data with other applications or with other institutions or reporting to governments, whatever. Now, there are also FHIR servers, and those are servers that have taken the general FHIR standard, said, we're going to write a piece of software that does FHIR. And so they implement all the features of the standard and provide general stores that are FHIR compliant. And there's quite a lot of them now. They don't do anything. All they are is a general purpose tool that does FHIR. And then you write applications that sit in front of them that actually solve problems. But there's nothing special about those. You don't need to use them. They're not what we exist to create. Our purpose is to foster exchange between applications. And so any healthcare application can implement FHIR by using it for some kind of exchange, be a client or a server or a website or a stored procedure or a mobile app or a desktop app. It doesn't matter. You use FHIR for the things you need to exchange. You can also choose to use FHIR inside for everything, and then everything you do is easy to exchange. But you don't have to do that. So here are some questions from yesterday. If you have a complete solution, what would it take to be FHIR compliant? Well, you need to exchange data with whoever you exchange data with, or at least one of them, following the rules. From our point of view, it's a black box. Your application, we don't care what's inside the black box, as long as when you interact with it with FHIR, it meets the rules. And so you just have to make it meet the rules. And you can choose how you exchange. We offer multiple different ways of exchanging data for whatever is convenient. And usually a community gets together and goes, we're going to solve a problem by exchanging data with each other, and we'll choose one of these ways. And mostly people choose the RESTful API, which is what you mostly hear about, and that's fine. Can you integrate to it, or do you have to rebuild your app backend completely? You integrate with FHIR. You don't have to you do have to make, my experience is you have to make changes to do that. Because someone says, patient name has, X number of characters, and it has these bits, and it has a use code on it, and you go, we don't have a use code. We're going to have to do something with use code. And so you have to make lots and lots of little changes to make sure you get the information requirements correct. But you don't have to rewrite your back end. You can rewrite your back end and totally use FHIR as storage if you want. But nothing we do says that you should or that you have to. If you are a DHIS2 developer, for instance, you could look at DHIS2 and say, it would be really fun to rewrite it from scratch and use one of the general purpose FHIR servers in the background. I would not recommend that, and they have not done that, which is a good thing, but they could. And in fact, given the availability of Happy and other servers, people are now writing new applications using FHIR at the back end. That's good because everything about it will be interoperable, but it's not necessary. And it's not even what we develop FHIR for. Like if you come to us and say, well, I'm writing an application with FHIR and it's not the most efficient way to do things, we go, good luck. We don't really care about that. Our focus is exchange between applications. You want to use that internally, you can, but that means, for instance, that our exchanges are quite unnormalized, denormalized in the technical sense. Our focus is resilience, not efficiency. Right? You can make it as efficient as you want, and I've got some questions about performance I'll get to later, but that's your problem. Our problem is optimizing exchange between applications. And you might find some things you need to do, like manage your users, that we have said, nah, that's not our business. Some other standard handles that. And we won't change that because Happy or Smile or Google or Microsoft would like us to. It's not our business. So you can, and people do, and they do at real scale. I've seen national clinical applications running an entire country built on single servers. And actually, there's kind of a call, maybe I'll get back to this later, for a hybrid approach where you store everything in FHIR, but you pull out the bits you care about running really quickly and do some other kind of SQL-y thing or whatever to get on top of performance, because that's not our focus, right? But it's really good to have everything in FHIR, really robust, really resilient, easy to work with. But just because you can doesn't mean you should. And there's a couple of real challenges. One is that we're really good at handling data, and you can put together really quickly a very large database full of FHIR resources. We haven't told you anything about how you architect that and how it all fits together and how you manage that as a set of content that people work with. We give you some tools, but we don't give you any advice. And so you need to think about that and think about how higher level design patterns need to be used. That's not our business, other people's business, but you still need to do that. And the other thing is, it's not unusual for clinical applications to present users with a list of what they could be doing next. Very common, in fact, some kind of a work list or a job list. And a typical clinical application in a clinical hospital, particularly a hospital scenario, will have 25 different kinds of users. Each user is sitting there in front of the computer with a list of things they could do. Maybe there's several hundred users or several thousand users, and preparing each of those lists is something that happens all the time. It must be done really, really quickly, and it requires a lot of processing to produce the correct list. And it's not unusual for creating those lists to hit 50,000 resources as you borrow through the information to figure out, you know, who's the list of patients that they should be reporting right now, or who's the list of patients sitting on a seat right there that they could call in. That is really hard to make it perform if you just have FHIR. So we love FHIR. It's my life. I love it, but it's not everything. And if you're writing an application and you set out to write it on FHIR, these problems are going to come up and you'll have to solve them somehow, and it's not our business to solve them. Our business is exchange standards, to help people exchange data and create a platform that makes the healthcare system, not any particular application, efficient and effective. So hopefully that explains where FHIR fits into the picture for you. So you can use FHIR for applications, great, but it's not our core purpose. Now, the other thing to know about FHIR is it's not the only standard you need. There's terminology standards, there's exchange standards, there's security standards, there's standards for application behavior and rules about how applications should behave, and then there's rules about the clinical process and clinical workflows and billing and business workflows. They're all different kinds of standards. I'm just trying to explain where FHIR fits into that picture. So a terminology standard defines a set of concepts to, and hopefully, not always, but hopefully you get good, clear definitions of those concepts and you get codes for the concepts and you can share codes with each other and know that you're talking about the same thing. And so typically they're the words that computers can say to each other. And there's a bunch of terminology standards, LOINC, ICD, the ICDs, ATC, NDC, and RX norm, and UCOM. And W3C defines some, and HL7 defines some, and every lookup table you've ever seen is kind of, by implication, a terminology. And there's OCL, which is Service to Manage and Define terminologies. Knock yourself out with all of those. And you have to deal with lots of them. And in fact, it's quite painful. And because it's painful, FHIR says you can work with any of those. We don't, it's not our business to tell you which one, and often you'll have laws that tell you which one. And so we defined a terminology service that helps you use all of them. And so in various countries around the world, we're now seeing a national terminology service roll out, and the software vendors are moving to using that. And then they don't have to do all this work to manage all these terminologies, each with their own requirements. It's all just a terminology in a service, and I don't have to think about it anymore. And so I highly recommend to all of you that you start thinking in terms of moving all of that terminology stuff off to a specialist terminology server. There's all sorts of problems with doing that, but it's less problems than doing it all yourself. So then there's exchange standards, which define what things can be said and when they can be said, a grammar and a conversation protocol between computers. Because the thing about computers is they're super stupid. Even when I program them, they're still super stupid. And even with AI, they're just more creatively stupid. And so someone needs to say what they can say to each other in order so they understand each other correctly. And so we define sets of data that can be exchanged and how those exchanges map to real-world clinical problems that the healthcare system actually has. So those are exchange standards. And given that they're the things that go backwards and forwards, they get a lot of attention. FHIR is an exchange standard. But they're only really useful when you match them with all the other things filled in, right? They're just a technical standard. And so there's lots of exchange standards, not all in healthcare. HTTP, HL7 version 2, CDA, XDS, lots and lots and lots. I didn't bother listing them. And then it's FHIR. And in healthcare, FHIR is overtaking all of them, but it's going to take decades. I'll be dead and gone before those others are gone, right? Because people just don't change stuff that they've already done if they can possibly avoid it. It's a 70-year life cycle. And that's okay. We're here to make it easier for you to do your job, not to take over the world. But we can do that because we can do everything they can do, but better. And it creates a platform, it's open, we do terminology better, lots of tooling and open source, and most of all, an awesome community, and here we are. But like I said, it will take decades. Then you need security standards, protocols, best practices around security, authentication, audit logging, safe programming styles. Some of these things are really basic. Some of them are comms protocols, crypto stuff. Some are healthcare specific. You ignore them at your peril, even though clinicians are not fans of security. And so here's a list of some of them. I'm going to talk about them, but there's lots and lots of them. We in FHIR, we mostly say we're not experts and we don't want to create new protocols for security. We'll just use those. But we do have various specs that talk about how to map those others and how to use them in the context of using FHIR, around OAuth and ZACML and so forth, to explain how to put together a platform for healthcare. Um, so we do have some FHIR-specific things, and there have been some very specific hacker attempts to hack FHIR itself. But of course, FHIR is just a set of rules. You can't hack a set of rules, but you can hack the products that implement them. And so there's some high-profile commercial hacking in the States to try and prove that systems using FHIR, as the government requires, are not secure. And it turned out all the ones that were not secure because of stupid programming things that should never have happened. So everyone should just pay attention, because you will get hacked, and FHIR makes it easier for you to get hacked. It also makes it easier for you to get it right. Then there's application standards that define expectations for what applications do. These are actually what consumers think of when they talk about standards, right? How does the application behave? We say almost nothing about that, right? That's some other place. And they're often made at national level, or there's clinical standards from clinical communities, WHO specifications for smart apps, for instance. Our business is to help that, to support that. They mostly come to us as requirements. We need to do this. We're to figure out how to do it with FHIR. Can you help us? Yes, that's our core business. So we publish implementation guides. Mostly other organizations publish them, and we just help, because the whole purpose of the exchange is to meet the requirements of the application. It's pretty unusual that the exchange itself is the actual point. The exchange exists to serve some point. And the same for clinical and business standards. They define expectations for how users of other standards behave, and so they're things that we need to make happen. And usually they're agreed to by clinical professional societies and so forth. And our business, again, is to support those. So FHIR by itself is a technical platform that makes it really easy to scale your solutions to those things. But those things are the things that actually matter. They're the solutions to the problems we have. FHIR is just a building block for those, right? It's as good as the one as we know how to make, but the point is to support those other standards that matter. And that has caused me trouble at times, because people, particularly governments, they hear, oh, FHIR is this international standard from other countries, Europe and America, and they're going to make us do particular things particular ways. No, we're not making standards for how your applications and your healthcare system works. We're making standards for how technical things support the decisions you make. It's not our business to force you to do particular things in your healthcare system, right? But it's pretty easy for governments to fail to see the difference. Particularly some languages don't make it easy to distinguish between those. So if you're talking to people, it's really good to draw a distinction between technical standards and behavior rules. All right. So exchange standards get lots of visibility, but they all matter. Now let's talk a little bit about performance. So these are very deep, techie questions. How do you make sure your approach is performance? What pitfalls are there? If you're running a server, the more indexing you do, the more search you support, but the slower it is. You have to do the work. You can decide whether you store FHIR natively or whether you pull it apart and store it in a database. There's trade-offs there, engineering trade-offs. I can't tell you which is correct, but I do have more to say. What you need to do is pay particular attention to the size of your transactions. Lots of smaller transactions is one kind of problem. Less really big transactions is a different kind of problems. most of all, you need to pay particular attention to subscriptions. If some other system needs to listen to what's going on, that can be really hard to make performant. And for clients, pay attention to the trade-off between how many requests you make and how big the requests you make are. If you make lots and lots of little requests on a slow link, you get a real latency hit. But if you make you make a very few big requests, you might blow your available memory on an Android device, for instance. And so these are trade-offs you have to figure out. There's no general solution to that. So there has been some benchmarks around open source server implementations that found them not performant at scale. What recommendations would I have for large-scale deployments? So first of all, I want to point out that those benchmarks were done by the non-open source providers seeking to demonstrate that they were better than the open source providers. So the first thing they did was figure out the rules of the game to advantage them as much as possible. But it's not the same rules of the game as real-world implementations, right? That's just marketing. But there's real arms race at the speed end from the commercial vendors, but some of what they're doing is spilling into Happy, and so it's better than it was. But from where I sit, they're now, small CDR team is working on uploads where they measure them in millions of resources a second. That's fast enough, right? Unless you're doing bulk upload and spinning up clinical data repositories you're going to knock away tomorrow, millions of records a second is like ludicrously fast. So I don't worry about that anymore. Also, totally depends on what kind of a system you're doing. But how efficient is it in terms of search query for large data sets? The single biggest deal is how well you can explain your query. But it's really common to go, I can't figure out how to narrow the query down, so I'm going to select a set and then do my own analysis on the set that I get back. The nearer you can get to expressing your full analysis, the quicker it's going to be as a total outcome, even if that makes the server slower. How well does the indexing work? How efficient is the processing? How big is the result set? How many includes have you got? How much are you getting the server to do? But these are all trade-offs. There's no simple answer to this, except that I'll tell you this. I sat and watched presentations in the past. People spent 6 months assembling the data and working the data over to get to the point where they could answer their question, and they could have done it in 90 seconds if they just had a FHIR server. Because those are the kind of efficiencies around design that actually matter for me. I wish I could tell you more, but how long is a piece of string? These are engineering challenges. So here's a quick one, that's a totally different change, but if you're interested in CQL and Smart, how much can we depend on CQL? So a couple answers here. High-end clinical decision support, the sort they're working on in Europe and America, is going to be, custom code with a huge amount of scientific verification and lots of Gen AI. And I get involved with these companies in Europe and America. They're spending half a billion dollars getting their AI and their CDS right. But they're not doing it in CQL. They're not going to do it in CQL. These are massive investments. I mean, they're wasting their money, but I can't tell them that. Or at least I tell them that, and they don't care. They don't listen to me. But then if you're not one of those companies with, like millions of dollars of venture capital to throw down the drain, then you can use SQL and FHIR view definitions as an alternative to CQL. And if you're in this space of CQL, you should have a look at that. Or you can just say, no, we'll just write custom code with TypeScript and WebAssembly. Nah, those are not great ideas. So mostly people are converging on using CQL for sharing clinical knowledge about clinical decision support. But in the end, that runs out of steam for really complicated, really high-grade clinical decision support. But for me, it's a really bad business model right now. And I would keep out of that space. So CQL works for now. And more generally in AI, what's the role of standards in a world driven by AI? And you know, we had an actual HL7 meeting about this a couple of months ago, and half the speakers got up and said, we don't need structured data anymore. We don't need standards anymore. We've got AI. AI will do it all for us. And the other half of the speakers got up and said, that'll never happen. That won't work. The problem with healthcare is this long tail of complexity. You're doing telecoms or airlines or whatever. When people come to you and need support, for instance, there's a set of basic, simple problems that they have, and you can solve 99% of them and tell the other 1% of the population you don't care about them. It doesn't cost you very much money, and you can do that AI and make it work. But if you're doing health, it's just not like that. And you can't go to the last 20% for super complicated patients with lots of things going wrong and who don't fit into any of your well-established boxes, say, we don't care about you, you can just go die. But it's just not a thing that happens. And so in AI and healthcare, you have to worry about the tail. And the tail is what creatively AIs get wrong. So for me, my opinion is that we need more data. We need better data. We need more data, and the appetite for data in healthcare is just going to grow. And one cost recovery mechanism in the developing world, which is already getting going at scale, is selling your healthcare data to the first world for data analysis in FHIR, because a lot of them are using FHIR for their data analysis. But fundamentally, we don't know the answer to this, and it depends on your goal. I was in London last week, and one of the chiefs of the National Health Service in London said, forget the long tail. I don't care about those people. Clinical documentation is already so awful. Clinical decision-making is already so awful, AI can't be worse. That's a tremendously depressing thing for the leader of the NHS IT to say. Wasn't the actual boss, but still. So what is it you're trying to achieve? It's your decision, but I don't think we know yet. All right. In terms of toolbox, tools. We provide a bunch of tools to get you going. Everything we publish is free. Standards, documentation, training. We provide a validator free against the standards, an IG publisher, so you can, oh, whoops, I copy-pasted that by mistake. So you can publish your own documentation. It's all free. Registry.FHIR.org is a full index of everything we published anywhere. Terminology servers, libraries, Google's health stack. Yay, Google. Thanks, Jing and Fred. Happy, general purpose FHIR server, and there's commercial variants. This is an awesome toolkit to get you going. But in the end, you actually have to solve your own problems. Now I'm going to hand over to Diego, and Diego's going to tell you about what's going on around the world. But while Diego's getting set up, I'll take a question or two if you have any. 5 minutes. Okay. While Diego's getting set up, anyone got any questions?
Opportunity to ask your burning questions.
Thank you very much for your comprehensive presentation, the good father of FHIR.
Thanks.
So my question is quite very specific. I just want you to explain the relationship, I could say, between FHIR and OpenHIE. How can we use FHIR on OpenHIE, and maybe specifically a lab management system which uses a standard such as LOINC? This is a specific country context that I'm actually asking about. Thank you.
So our friends at OpenHIE started on their journey before we were really going, and describing how to do health information exchanges, and I loved their work. And in the last 6 or 7 years, they've been gradually changing their work to focus on how to use FHIR to do those things. And we work with them to help them to figure out that. And it's a process that's ongoing. As far as I know, they're happy with that process. I haven't heard otherwise. But HIE is like an application level standard rather than a technical level standard. So our business is to support them in describing those standards. This is not the only way that you can use FHIR, but if it's the way you do it, that's great. We're happy with that. In terms of LOINC, most FHIR users around the world use LOINC for the things that LOINC should be used for. And we collaborate deeply with the LOINC team. And that's all straightforward and good, as far as I know. That's, you know, our role is to support all those things to be used. If you have like really detailed questions to follow up, we can do that, but not now. Right, any other questions? This one over there.
Thank you. What can be your advice on someone that is just wants to use FHIR for data exchange? Should they learn something like SQL on FHIR, or they can write their custom code for data query?
So the first thing is that you should choose a development language that has a good FHIR library available, like Java or .NET or Python or whatever, and then use that client or that library, either on the server or the client. That gives you a huge help to not worry about a whole bunch of details that you would otherwise have to pay careful attention to. But you will have to write code to do what you want to do. And so the first thing, once you have chosen your environment and grabbed your library, is to do one of Diego's amazing courses at HL7 that teaches you how to think about the problem you need to solve. And then, honestly, what I do when I'm doing it is I use Postman to make sure that I know what's going on the wire, and I usually work in Java, so the Java happy client to do my work. But you know, it's definite advice to use one of those existing libraries. They just save you so much work. But I mean, people don't, and there's one for JavaScript as well. Lots of people who write apps, particularly client-side apps, web apps, for FHIR, just use JSON directly and write their own code for everything they want to do with JavaScript. But for me, it's just hard work to do that when you could just use someone else's work who's already done a lot of the legwork. Yeah. More, or we hand over to one more? Okay, one more.
Yeah, thank you so much. Just wanted to know what would we expect when moving to other versions of FHIR? Say we have implemented FHIR version 4 and I need to move to version 5.
So we had really big discussions about this last week in Lisbon, where I was at a FHIR meeting in Lisbon. And the answer is, if you're on 4, you probably should stay on 4 and not move to 5. And when we move to 6, which will come out late, end of next year or early the year after, we're a big push to move everybody to 6. And we know that we have lots of work to do to get that, to help people make that transition. But it will be a mix of code and examples and services to transform from 4 to 6, and also lots of teaching around that. But actually, I don't really know what that looks like. It's just we know that we need to do that. For now, that's where we are. Sorry.
Okay, let's start then. Well, I will try to go to what we have in terms of FHIR adoption and what kind of global tools we have. You can read this, I will skip it. I'm not Graham, he's there. So we will review our mission, some global technologies, global international guides, and some, not all the regional implementation that we know, because it will take 2 hours or more. So I just selected some of the countries and regions to give you a brief description. So in our mission is to provide standards that empower global health data interoperability. The things that you see in green are countries where we have affiliates. The countries in cyan color are the countries where we have a regional partner, including Helena in Africa and AHIN in Southeast Asia. And the 2 more recent affiliates are Ecuador and Central American Dominican Republic in Latin America. But the real community is this one. So here you can see how many people in each country is registered in one of our sites or in chat.fire.org, everywhere. So let's first review the global FHIR toolbox. FHIR is not just one standard, it's a standard family with several technologies. The first part of the toolbox is what we already talked about, is the FHIR core spec. We define a series of API methods to exchange what we call resources, and we also define the syntax. And that you can find in hs7.org/FHIR. On top of that, there is FHIR implementation guides. So FHIR itself is not enough for any specific domain or country, so we need to create a profile to cover that specific domain or country needs. Then we have Smart on FHIR, defining security roles and how to launch one app inside of the other, inside of the EHR, for instance, or a portal. You have CDS hooks, which is an API for clinical decision support. So how to call another system for knowledge. So I have this patient with this context and data, and I want to apply certain definitions or knowledge, but I don't have it locally. So I call another system, how to call this system and get the results back. Bulk data access, when you want millions of records from a FHIR server, not just records about the patient, but population records, you cannot do that in a synchronous way. So bulk data access allows us to call these systems in an asynchronous way and get a set of files back. And each file may contain hundreds of or thousands of records. And finally, CQL, which is a language to express knowledge and to define measures. So how many patients that I have comply with this specific criteria, and how much of them are being treated correctly, or for a specific patient, having a calculation of the gap of care. What is the next step for this patient to be treated along with the specific guidelines? So first, the FHIR spec, fast healthcare interoperability resources. The last version was release 5, as stated by Graham. If you go to the site, you will find a yellow bar, and that yellow bar will tell you how to see other versions of the same page. FHIR defines an API platform for exchange. It doesn't define everything. So we know that transport can be HTTPS or others. The security will be auth or whatever you have as security. The syntax was XML and JSON and RDF, but most implementations are using JSON. Some of them are not allowing any other. It's JSON or nothing. The structure we define are the FHIR resources and data types. That's the core definition that we create. The methods are usually the HTTP methods: get, post, put, delete, and patch, but you can create your own operations, and some of the operations are already defined in the standard, like validate or get all the candidates, patients for a specific demographic set, or create a questionnaire and populate. Those are specific operations that require that the server knows how to do specific things, not just HTTP methods. And finally, some terminology, not the clinical terminology, but the structural terminology is what we define in FHIR. So FHIR is the web for healthcare. About profiling, we will go deeper in the next session, but we can profile the server behavior, what the server is capable to do, which resources are supported by the server, which operations in the server, whether we use RESTful or other paradigms, which version of FHIR we are talking about with this server, what the server is supporting, which search parameters the server supports for each resource, whether it supports any extended operation or not, and finally, whether it supports resource versioning or not. So for each resource, you can keep the history or just keep the last version. And the server needs to tell you what it's capable to do. And then for your specific use case, defined by the profile, you need to specify mandatory and unsupported elements, slicing, which is for specific repetitions of each element, which values are valid. Then anything not covered by the standard is called extension, and you have to define your own extension for your use case. The terminology for coded elements, for your specific domain, for your specific use case, you will use these codes in this element. So you need to specify that also as part of the profile. And finally, when you cannot make elements mandatory, but they are not also optionals, we call that must support, something that the systems need to send if they're capable of, and they can have to process if they receive them. So that's for each resource you use in your use case or domain, you need to define that. And we need that because an implementation guide is a set of profiles that will be used for solving a particular problem. An example here, it's the American government, the US government created a set of data that was mandatory for exchange. That is called US CDI. And it's logical, has no specific implementation. It's what they regulate as needed for exchange between systems in the US, at least for patient access. But the actual implementation of that, how to actually exchange that as bytes, it's an implementation guide called US Core. So we go from the conceptual definition for the exchange to the actual definition as a FHIR profile. So we define FHIR, which is the general structure and methods. Then on top of FHIR, the use of FHIR in a specific country or region. And then for each clinical domain, on top of that, we define what we want to exchange. Let's see the difference. Oh. So here you see, have you ever seen this? Hands? Patient? Everyone. So which element is mandatory? Which element is mandatory? You have seen this before. Which element is mandatory? None. No element is mandatory because this is abstract, this is generic for everyone in the world. So for you, for your country, for your region, for your project, some of these will be mandatory. So let's view US Core. Oh, I don't see the snapshot here. So here you can see in the same table, but for US core, that there are some elements that are marked 1 to many instead of 0 to many. So for the US, these are the required elements. You can also see some of them marked as must support with an S. So they are not mandatory, but they should be there if the systems can have the information or can receive that information. So that's the difference between a profile and the base spec. The base spec usually is very abstract, very generic. So there is use of extensions, something that are specific to the country that we add. Terminology restriction, we will use SNOMED or we will use LOINC for this specific field. Cardinality will change. Instead of 0 to many, 1 to something, sometimes many, sometimes 1. And behavior, we want you to support these search parameters specifically. Not everything in the FHIR list of search parameters for the resource. This combination is mandatory. So when you test any server, you can make sure that those searches are supported in that server. And what we provide for profiling are mainly two things. The IG publisher, which given your specs will create this implementation guide for your domain or country. And we also provide what is called the language for defining this profile, which is called FSH. It's a standard language. So with FSH, you create your profiles. With the publisher, you go from the profiles to the implementation guide. Let's review now some FHIR global IGs. The first one is the International Patient Summary. We will go through that in the next session. The second one is International Patient Access. The International Patient Summary will create a document with a snapshot of the patient problems, conditions, immunizations, current medication, and some other things. The International Patient Access is the same idea, but instead of creating a document, giving granular access to this information, giving granular access to patient demographics, to allergies, to immunizations, etc. The WHO Smart Guidelines, you will go through that tomorrow. In the past, the guidelines were a book, and now they are computable. So how to go from the book to make them computable and make them accessible by the healthcare workers on site. ESAVI is a Pan-American report of immunization-related adverse event for 42 countries in South America, how to express the adverse events on immunization in a coherent way in all the continent. And finally, LACPAS is a way to use IPS for immunization record or patient summary along all Latin America. We will see the International Patient Summary later. This is an overview of the SMART guidelines. In the first level was the previous book, let's say. It can be modified at the regional level, and then it can be made machine readable using TQL to express the rules for a specific country. So let's go now with the regional FHIR implementation status report. Remember, this is not exhaustive. I just selected some countries and some regions to show you what they are doing in this field. Let's start with Asia. And here you will see the first concept that will be repeated along the way in most of the countries, which is the creation of the core IG. The core IG usually will define how you identify your patients, how you identify your providers and your practitioners, your hospitals, organizations, and practitioners, and how you classify them. because that's unique for each country. So that's the first level of the core IG. Then you will also define what is common for all domains in your country. For instance, if you have some specific terminology for medications, you can declare it as your part of your core IG. So in this country, we classify medication and we identify the medications in this way. So usually the terminology used in a specific country and the definitions of the entities that play roles in the healthcare space in the country are part of the core IG. So you will be seeing this repeatedly along this way. Some of the countries also include in the core IG the same that the US did, what we need as for patient access for exchange. But I prefer a two-step framework. First, define the entities and the terminology, and in another guide, define the domain-specific problems and solutions. So Taiwan started the core IG 2 years ago. They have the first release, and then they are starting to create things over this core IG, infectious disease report and PHR from EHR on FHIR. The same for Japan. In this case, you will see that other than the core IG has a lot of areas, but the main area is administration and how to define patients, location, organizations, coverage, and encounter for any exchange in Japan. And then the other more specific, domain-specific areas for access. I was in Korea 1 month ago. They have created their first core IG, and they also created an agency that will do FHIR education and system certification. So this is the guide, this is how we will manage our exchange, but we also need to be sure that we can test the systems. So that's the idea behind the agency. They will provide testing to make sure that the systems can support this IG. And also they are creating some shared workflows using this technology. India has the biggest FHIR project in the world, already 600 million patients registered in September. This is the FHIR guide, and this is the project description. It's right now mostly document-based. They have defined a diagnostic report, discharge summary, immunization, consultation, and prescription. And it's also tied to payment, so they will not get the money if they don't send the documents to the repository. Singapore has created a system not for patient access, but for patient reporting of his or her proactive approach to her own health with connections to the EHR for wearable devices. It's called Healthy Singapore Program. Indonesia has running the second bigger project in the world. It's called Satu Sehat. It's a FHIR store-based. Google set up a data center in Indonesia that is holding all this data for all the patients. More than 200 million patients registered and using the app. The app is just access for patients for their own data. So every system in Indonesia has to send whatever they have done to the patient or whatever information they have for the patient after the encounter, and the patients are able to see that information in their phones. This is what Graham told you about FHIR Store. They are actually storing the resources in this repository. It is for exchange because there is an app for the patient that reviews his own information or her information, but the exchange is based on storing data in a server. Malaysia also have this kind of project. They have 2 levels. The first level was about secondary data analysis, but they are also creating a core guide. It says my, but it's Malaysian, not my. And that's the health information exchange, and they have sections for all of this data that you see in the right. I have included all the URLs so you can see it yourself and judge. Let's talk about a little bit the US. The US based its advance in FHIR mostly on accelerators. There are some of them. I will go fast describing each one of them. The Argonaut project was the author of the US core, passing from the concepts to the actual implementation, and also some of the technologies we review at the beginning. Da Vinci and HS7, Da Vinci is about payer to provider relationships. So when a payer wants some information from the providers, or the providers want information from the payer, or to solve a prior authorization when they have to pay and they don't know if the patient is allowed to have this service or not. That's Da Vinci. Gravity is about social determinants of health, how non-clinical issues like hunger or transport can affect people's health. Karen is about the relationship between the payers and the consumers. How much will this medication cost for me if I have this insurance? Or what was the last thing the payer covered in my healthcare? Helios is about the relationship about within public health and the providers and how to improve it. Codex has all the clinical domains. They have oncology, the oncology terminology and workflow, cardiology, and genomics. How to represent, for instance, the difference between my own DNA in specific segment and the pattern for this segment. So that's Codex. FAST is about how to implement FHIR at scale, the things that you were discussing about performance, about identity of the patients in large scale, about security. And finally, Vulcan, which is how to tie research with clinical data, how to get real data, real world data for research using FHIR. And also how to represent clinical trials and their outcomes. The USA is actively regulating the use of FHIR, mandating, like one of our speakers told us at the beginning of the previous session, it's okay to, okay, this is what we can do, and it's different, oh, you need to do this by the end of the year. It's a different message. So the US is heavily regulating using FHIR. In Canada, 2 lines of work. One is about the pan-Canadian IPS, so how to exchange information between the Canadian provinces using IPS. Also, they are doing a very hard job of defining a lot of pieces of information using FHIR for future IGs and the Canadian core. And a lot of use in the provinces, usually bottom up. In Latin America, very briefly, Chile has the law on sharing EHRs, and they are doing a connectathon next month with focus on the IPS for Chile and the core implementation guide and e-prescription. Argentina has the FHIR. I'm from Argentina. We define FHIR as the backbone of our shared digital network, the master patient index, the use of IPS for exchange, and also FHIR for e-prescriptions. Brazil is adopting IPS for private to public sector relationship, but also creating the Brazilian core. Colombia also created the Colombian core guides last month. They published them. I will not talk about Africa because you are here, you know better than I do, but you heard the CDC guide earlier, and that's the line of work. About Europe, The main project, they are European projects. They cover all the European Union and are some specific country projects. About the European project, the most important ones are EHDS and Expand DH. And the idea for them is that in 2 years, there will be regulation in place and implementation guides created to cover these use cases. So a lab report can be created and read all over the European Union. The medication prescription and dispense can also be interoperable along all the European countries. The discharge report will be the same, and also radiology reports will be shared along all the countries, and also a variant of IPS for Europe. So those are the 5 domains that will be regulated. In 2 years, the IGs needs to be present, and in 4 years, they need to be implemented. That's what the law says. Those are Expand DH and the European space. Another interesting project is Gravitate Health. They publish a standard to represent the medication pamphlet. You know, when you buy a medication, inside there is a paper that says what are the effects of the medications. It's electronic now, and that's called EPI. But they merged that with IPS, and in IPS you have your own problems, conditions, medications, immunization, and other information about you. So if you mix the pamphlet, the EPI, with the IPS, you can understand what areas of the pamphlet of the adverse events or the adverse problems that this medication may cause on you. So the viewer of the pamphlet will highlight what applies to your demographics and your set of conditions. That is called G-Lens. Unicom is about identification of medications. I will not go through that. And the last project, the European project, is Hospitals on FHIR. They have hundreds of hospitals reporting what they are doing with FHIR. It's a bottom-up approach. And they have defined several levels of adoption in Europe. Then some specific projects. Belgium, I think Jose is here. I don't know if he's in the room, but Belgium is very advanced on definition of the core and all the specific domains. Austria, the same. They have a very old system based on CDA, but they are slowly progressing on creating the US core and all the different domain IGs. Portugal is creating the core IG and terminology, and also adopting the European core for lab exchange. Swiss also very active in creating the core guide and all the domain guides. And France has this interest project called Mon Espace Santé, which is, again, personal access, patient access to health records using their phone. So basically, you can access your vital signs, laboratory, any clinical document, and appointments. You can see that the approach is different in each country, but the common thing is that they are creating a core guide and giving access to patient to their data. And finally, Australia. In Australia, there is a project called Spark. And Spark is not just creating the core, but also creating some of the specific domain guides. They started by creating the guide for e-requesting, which is the order for labs and then the report. They create the FHIR implementation guide. They are creating testing and piloting programs, and also creating and bringing terminology services and reference implementations. So with that, we see that there is a lot of variations on the approach. Maybe the generic trend is first, legally enable trust and consent. Who can share what with who? So the patient needs to be able to state their preferences. Usually, in the past, we use an opt-in method. So patient needs to say, okay, I want to be part of this program. I want to share my history with other providers other than this one, and that doesn't work. Opt-in programs usually doesn't work. So we are going through opt-out programs. If you don't want to share, you need to be certain that in an application, web, or when you are with a clinician. So first, registries, patient, provider organization, then terminology access, co-systems and value set. We will go into that later. Then patient access and clinical or document repository. This is the general trends we see in country use of FHIR. There is a lot of discussion because how we go from FHIR to US core to regional to national to local. And I heard Graham last week telling us no more than 3 levels. So how can we do this, not as a law, but as a recommendation? So how can we go from FHIR to our IG and then to our project IG, being cautious on not creating a forest of implementation guides? And finally, as a general discussion, what we need in every project, it doesn't matter what we are doing clinically. The bottom part, what we call the infrastructure, is first. You need to know who your providers are and who your organizations are. You need to establish patient identity. And for each one of these boxes, there is an implementation guide or a set of resources covering them. So you need to establish patient identity. Who are your patients and how can you identify them? You need to establish consent. Who can see which information according to the patient? That can change over time. Also, authorization and authentication. Are you the person that you are saying as you are? And which information can you see based on your credentials? Terminology, not only defining the terminology, not only creating the concepts and the value set, but also maintaining and giving our developers access to this terminology using FHIR. We will cover this later, constraints, extensions, and validation. How do we know that the FHIR thing we are using is correctly built? That's validation. How can it enlarge the FHIR spec to my needs? That's extensions. How do I know that I only use what I want in FHIR? That's constraint. So that's a specific part of the FHIR spec that we will go over in the next session. Transport, how we exchange data. Are we using REST? Are we using FTP? Are we using mails? What are we using to exchange data? And finally, audit log and trail. There are a set of resources in FHIR used to express who created this record, when, who saw this record, and when. And then you can be creative and do all the other stuff. Public health reporting, clinical decision support, document exchange, granular or clinical access to data, referrals and continuity of care, diagnostic orders, pharmacy, IG, the e-prescription, and immunization card. That's just examples of what you can do once you solve the things below. And I'm done with this part. I don't know if you have questions.
Especially with the US example and the IGs. I'm less familiar with that aspect. I'm a bit more familiar with the IHE way of profiling standards and testing conformity. How does this relate to what you presented in the the IG process?
Well, the good thing about IHE is that they are adopting our way to express profiles too, slowly. Because in the past, IHE profiles were just a document. The difference, and we will cover that in my presentation, is that FHIR profiles are computable. By computable, I mean that you can give a server the profiles, and some tools will tell you if your artifact is or not compliant. That was not possible with the IHE guides because they were text. So they are starting to publish all their IGs, at least the FHIR-related one, as FHIR profiles. That satisfy your question?
Yeah, maybe also because you mentioned that there is a risk with every country having separate IGs to have like a multitude of so much diversity that it gets hard to manage.
Right now, even when we are seeing that and we are discussing how to make it easier and less diverse, the diversity is not in FHIR, the diversity is in the business rules of the countries. We cannot tell them, no, you have to use this. Graham gave us an example last week on they have to record for each lab order if the patient is or not an indigenous Australian person. And that doesn't happen in any other country. How can I tell him, no, you cannot do that in Australia. You need to use our IG, which is for all the world. I can, but the result of not letting people do what they need is that they will use anything else. Oh, FHIR, we cannot do that? Okay, we will use our own. We won't like that to happen. From the beginning, the definition of FHIR was do what you need with FHIR, not do what we want. If you are not in agreement, just...
Thank you again for the presentation. I think the last statement you said is really key to the sustainability of FHIR, because I've seen many systems which are so closed, which are more proprietary, but they're being declared as open, and you have to have a geek, maybe the original person like Graham, to actually come and tweak that system, so that system ceases to be open because it's very expensive even to maintain. But my question, I think I forgot earlier to ask that FHIR, you mentioned a use case in DHIS2, but we know that DHIS2 is primarily cross-sectional data. But when we are looking at this, the basic record in FHIR is the patient, but cross-sectional data doesn't identify individual patient. It's actually, an aggregate of patients. Then my second question is, how you also mentioned that what is this? I'm forgetting the words to use. Okay, I think maybe you can answer the DHIS2 question, and then I'll actually remember what I wanted to ask.
Can you repeat the first?
So the question is, how do we use FHIR on DHIS2 when we know that FHIR record is patient-based or patient-centric, and yet DHIS2 is cross-sectional? In other words, it's aggregate data.
So if you are using FHIR as a store, because FHIR it's a standard for exchange. So we define what you need to do to exchange data from one system to the other. And if you are using FHIR for storage, what you will get are FHIR resources stored. They will not be aggregated.
So you can exchange even the bulk data or aggregated data without.
You cannot
any
exchange
problem.
aggregated data because there are some. I'm lying. There are some resources that were created to represent aggregated data. Those resources are called measure and measure report. So in measure, you can define the numerator and your denominator for a specific population. And in measure report, you can use it for reporting a specific provider or region numbers on that measure. but that specific report, a specific resource for reporting. And it's not patient-centric, it's population-centric. But again, it's because you want to exchange information about measures. We will send the measure report to some central repository so authorities can see the reports.
All right, great. Let's continue on.
You want me to continue with the next one?
I think so, yeah. Oh, good.
Perfect.
Great. Thanks.
Okay, we have already gone through this. I will repeat it. So what we can profile, what we are profiling, we can define the resources that the specific server use or support, the paradigms, do they support RESTful or other means of exchanging information, which FHIR version these servers support. We have a discussion last week on servers that can support multiple versions of FHIR, but usually in your IG you will say, I need this specific version for this IG because all my resources are based on this specific version of FHIR, which parameters I am allowed to search for each resource, any definitions you have on your specific extended operations, and whether we support for each resource versioning or not. And then for each resource, what are the specific constraints in our case? Do we mandate some elements that in FHIR are optional? We will not support a specific element because we don't want them to send it. And one of the conclusions last week in our event was that you don't want to over-profile. If you create several constraints and then someone else wants to use your profile and you didn't think that somebody can use this element, you have already forbidden. And since profiles are hierarchical, you cannot inherit and then add something that is forbidden above. So one of the best practices is not to over constrain. So we went through this already. Let's talk about how we represent the constraints. So the good thing or bad thing about FHIR is that constraints or profiles, or in general conformance, is expressed using also FHIR resources. So we use the patient resource to represent patient information. And we use these conformance resources to express the constraints information or the profiles information. So what kind of resources we are using? The first one is the capability statement. How do you get a capability statement from a server? Anyone? How do you get a capability statement from a server? No? No one? Let's do it so we can try. I don't know if my server is working. Yes. So I just asked the server, hey, server, who are you? What do you know to do? That's the capability statement. So it begins with a resource. The resource is capability statement. Then who the server is, where is it implemented, which FHIR version it supports, which formats supports. In this case, it supports all the formats. And then as a server in RESTful mode, which resources it supports. And then for each resource, which interactions. Do I know how to create accounts? Do I know how to delete accounts? How to get the history of the accounts? How to patch a resource, an account resource? how to read the history or a specific version, and how to update. When you create a FHIR server, you decide what kind of services, what kind of resources you want to cover, to support. And the IG will be the consensus of your group on what a conformant server is capable to do. So you can create a capability statement in your IG, and you can compare the capability statement of the server to the capability statement that is defined in the IG. And by that, you can see if the server is conformant. So you know what is the only requisite for a FHIR server? The only thing that the server needs to do? No one? Answer this. So if you have any FHIR server, the first question is, what do you know to do? And based on that answer, you can interact with the server. If the server doesn't support medication, you will not use it for pharmacy. So we need to define, the first definition is what we need the server to do in our project, in our use case and scenario. Let's continue. What? Mm-hmm. That's the scope, yes. I'm old, I cannot see without my glasses. So the first one was capability statement. The part in the left of the diagram, this is covered by the capability statement. Then two special resources inside of the capability statement: search parameter, which search parameter we define for this specific IG. Usually, the search parameters will be the list that you have in the FHIR spec for each resource. But you can define your own. And you can also ask the servers to be able to support this search parameter. The definition for the search parameter is the type of the parameter, the name, and how to invoke it when you are searching. So if you are doing patient question mark, something equals something, then the first something will be the search parameter code. And then it will have a type. Will I use strings or numbers to search? That's another definition in the search parameter. And then operation definition. So you can define your own operations. What is required to define an operation? The operation name, whether it is specific for a resource or server-wide, and the parameters. What do I need to send to this operation? And then what I will get back. So that's the definition for an operation, and that's operation definition. And maybe the most important conformance resource is structure definition, because it allows us to define the extensions and also the constraints. In the case of the constraints, you will tell which resource are you constraining, and then which constraints are you stating about the resource. This is mandatory. This has this cardinality for my use case. That's the structure definition. And finally, the terminology resources. The coding system to store these terminologies in a server or to access these terminologies, and the value set to create sets of valid codes for specific elements. So with this set of resources, we create our implementation guides. There is also a resource called implementation guide that holds all these together. And when we use the publisher to create our implementation guide, a byproduct, it's what we call a package. And the package represents the constraints we created for a specific domain or use case. This package, as any NLM package, can be uploaded to a server and can be used to validate an artifact, which was our primary goal. So let's see validation. So what can I validate? I can validate just the schema. The schema is the structure that is a FHIR resource. So if I add some elements that are not in FHIR, like for instance, in patient, I can add in my JSON grandmother's name because I love my grandmother. I can add to my JSON this element. That's not a FHIR element. So if I do schema validation, it will tell me no. This element is not valid in FHIR. You cannot invent your own elements. Then there are some relationships between elements. Those are called invariants. So if this element is empty, then this element should be populated. That's an invariant. That's another level of validation. And finally, the structure definition, which is the schema plus the schematron plus any other thing we added to our FHIR definition of the resource, plus terminology. So those are not covering terminology, but if you say in your IG that the code for the condition should come from the Kenyan terminology for diseases, then this structure definition validation will make sure that that's true for your instance. So how can I validate any resource? Most servers support a specific operation, extended operation called $validate. So you can just post in a server the URL of the server, the name of the resource, and then the operation, validate, and it will tell you if the resource that you are creating is valid or not. If you want to make it conformant to a specific profile, you can just add in the meta profile tag your profile. So it will validate also that it's a FHIR resource and it's a FHIR resource for your use case or domain. Let's try it. I'm not sure my server is keeping me to validate today. I have others. Oh, here is the result of the validation. Let's see. Oh, you are not seeing. I was very happy about my server validating, and you are not seeing it. Now you are seeing it. So I'm doing a post to a FHIR server with the patient resource and the operation $validate with my resource. There. Hello? Yes, with my resource. So in this case, everything is fine, but the gender is females, which has no sense. It's not a code for gender. And the answer for the server was failed to parse request body as JSON resource. Error was element gender, invalid attribute value females, unknown administered gender code females. So the server is making sure that my FHIR resource is correct. In this case, this is not a profile. It's just FHIR. But if I add a meta element profile to my resource, it will also validate against the package for the implementation guide. Does that solve your doubts about FHIR validation and how it's different from IHE? The server knows. Sometimes you need to turn it off because you want all the information in, and then you do validation in a second step. But some people, that's an architecture engineering decision. Do we want to validate every time we ingest a resource? Because it will take time in some cases. So let's talk about extensions. Extensions are used when the standard is not enough for you. The definition of the resource is not enough for you. So you have something about the patient that is not in the standard. So how do you represent it? And that's the role of extensions. So you can extend resources, elements, and data types. So you can say, for the patient resource, I also want this piece of information that is not defined in the standard. And you have a way to define it. Then for specific elements inside of resources, you can also extend them, add more information. Like for instance, in birth date, you want to know the exact time, so you can extend birth date to with more details, or birthplace. And in data types, you can also extend them. For instance, a human name, the last name of the person in the standard is only one. Only one last name, only one family name. All over Latin America, we have two. The father's name, last name, and the mother's last name. So it's not enough for us. So we needed to use an extension called father family name and mother family name to represent our reality. So that's extending a data type. So the only thing that you need to create when you create an extension is giving it a URL. And the URL should be the place where you describe this extension, usually as part of an implementation guide. And the description of the extension is telling the world what it is good for, and usually the data type. And in case of a code, where do you find the code to populate it? So that's the simplest definition. You can define extensions of a lot of data types, like numbers, codes, dates, attachments, etc. And you can also define complex extensions. Complex extensions are just the definition of the extension, the URL, and then several data items inside of the extension. An example is the US core race. Let's discuss a little bit about terminology. So it's key to semantic interoperability. Remember, we have to define all the entities we are talking about, patients, provider, organization, but also the concepts to create semantic interoperability. FHIR will give you the structure, but you need the entities and the concepts. And concepts are terminology. So in this case, for instance, we have the structure for the observation, but you need a category and a code to state specifically which observations you are talking about. And you need to understand each other. If I send him my local code, he will not understand. So codes need to be as semantic interoperable as possible. The more global, the better. Examples of coded data, code, codable concept, and quantity. Those are the places where you will see, in terms of data types, terminology. In the first case, in code, you can see that it's just a code. We don't specify the system. Where are we getting this code from? Because that's part of the specification. In some other cases, we just said codable concept, and each project may define their own code, so we need to state in the actual FHIR JSON, where are we getting this code from? And we can use several codes for the same thing. and also include the text, the original text that the clinician wrote. So that's the codable concept definition. Important things about terminology in FHIR. First, the code system. It defines a set of concepts with a coherent meaning. All the codes for medications in the US, all the codes in SNOMED. SNOMED defines everything. All the codes in LOINC, those are code systems. So usually they will provide a code, a display, what it means in some language, and a definition, something more specific about the code or how to explain it. Then we have something called value set. And a value set is a selection of a set of codes from one or more code systems to use in a particular context. So if we say that the code for the condition should be ICD-11 or ICD-10, we are creating a value set. The value set is all the codes in ICD-11 and all the codes in ICD-10. But what happens if I want to codify, I don't have information about this? We need a third code, which is I don't know, from another set of codes. So the value set will be all the values in ICD-11, all the values in ICD-10, plus the codes for I don't know. That's a value set. And then we have the actual coded element. Remember in the condition, for instance, the code, we need to bind that to a value set. And there's something called the binding strength. So when the binding strength is required, you cannot use any other codes. So for instance, for gender, you can only use those 4 codes as defined in the spec. When it's extensible, you may use an alternate set of codes if you have to. When it's preferred, you don't have to use this specific set of codes, but it's recommended. And then there is another called example, where the actual set is not specified. 5 minutes in total. Then we have IPS. Okay. When you define a constraint or a profile, you can make this stronger but not weaker. So if you have a condition in FHIR, which is example, the code for condition in the spec is example, you can say, no, for my country, these are the codes we allow. So that transforms from example to required. In my country, we will use this. That's the profile you are creating. And also the concept of terminology services. So for all these complex interactions with codes and value sets, there is a lot of complexity on how to manage them. And usually our scope as implementers are very small. We only need to validate, to search a list of codes, to know the details about the specific code. These are the application needs. Give me a list of codes. Is this code valid? How do I show this concept in different languages? How do I translate this code into another code system? For instance, ICD-11 to ICD-10 or ICD-10 to SNOMED. And how to integrate terminology search into my app. So the clinician is writing diabetes and started with DIA, and I want to show a list of concepts. I can use a terminology server to make my life easier and solve that. And these are the operations for this. Expand, which is getting all the codes in a value set, and you can filter that. Look up, so you give the code and the value set, and it will give you the display. Validate code, knowing if a code is valid in a specific context. And translate, to translate one code to the other. Where you can find profiles, you can find profiles in all the examples I show you from different countries. You can also go to US Core. You can go to samplifier.net, where there are a lot of profiles around the world. And the most important one is the registry.fhir.org, where all the packages and implementation guides live. We talk about the tools for profile editing. In the beginning, at the beginning of FHIR, we use Excel and Word. Then some other tools were created, but now we are trying to move everything to FSH. So we write our profiles using FSH and publish them using the FHIR publisher. And I think I'm done before time.
Thanks, Diego. We wanted to cover a little bit around IPS before Carl talks.
You want me to go to IPS now?
I think let's do that, and then let's try to have some time. Is there any burning questions that people have? I know there's a lot of depth here, and for those that were in the lightning talks yesterday, hopefully you can see that some of the things that we tried to cover at a surface level yesterday to try to introduce some of those concepts, Graham and Diego are kind of going into at a higher, I suppose, at a more technical level. And I think you can appreciate there's a lot to unpack within FHIR, and it's a different kind of paradigm to be thinking about, the structure as to the way maybe we kind of sometimes approach development in digital health. So hopefully some of the dots are kind of connecting a little bit, and you can see how some of the tools that sit above the specification are helping you to make it easier to work with the specification and implement some of those things.
How much time I have? 10?
10 minutes, yeah.
Okay, let's go with IPS. So first, what it is. Basic clinical data, summarized version of a patient clinical data. It is not about an encounter. It's about the patient in general. This patient has these problems, these allergies, these medications, and that's it. If the minimum IPS is just demographic data and 3 sections: medications, allergies, and problems. How do you know which ones to include in specific summary for a patient? I don't know. It's your job. It says relevant information. Which of all the information you have is relevant? It's your problem. Or maybe you have a clinician to create it. Some mandate that. It's specialty agnostic. It doesn't matter which, if you are an OB-GYN or whatever, the same list of conditions will serve. It's condition independent, and was first created for cross-border emergency care. So it was the fruit of some European project on how can we know the minimum data about the patient before giving emergency care. Then they removed the emergency care. And now we are removing the cross-border or redefining border. For instance, in my country, in Argentina, we have 24 provinces. So if you go from one province to the other, we create an IPS with the patient data at that time. It's not cross-border because it's not an official border. It's a border between provinces or between regions. You can use it for whatever you want. It's an implementation guide. We discussed what an implementation guide is, a set of profiles. And as part of this profile, we use the composition resource in the beginning. That's the beginning of the IPS. And the composition resource inside of a bundle includes all the information about the patient. The required sections are allergies, medications, and problems, and there are other 11 sections. What is a section in the document? It includes some text, what they can read if they don't have anything else, and some pointers to structure information in the form of resources. So in the allergy section, I will have the allergies as a list in text in HTML, and then I will have the computable information about the allergies inside of the same bundle, inside of the same set of resources which define my document. So this is the IPS composition. It's inside of a bundle, and the minimum quantity of compositions is 1, and the maximum is also 1. And it includes the subject of the IPS, who is the patient, the author of the IPS, who created this summary. Sometimes it's a person, sometimes it's a device. Usually, I've seen more devices creating IPS. And then the sections. And for each section, the narrative text, what we will display, and resource references, where we will add more information in coded form. Coded meaning I can code the conditions using ICD-11 or ICD-10. I can code the allergies. I can code the medications. Not in the text part, in the resource reference. It will include references to patient, practitioner, and organization. What is this about? Who created it? In the scope of which organization? And this is all the composition. Patient, author, attester, custodian, who is in charge of the document, required sections in red, and then recommended sections in orange. In our case, we added immunization as one mandatory required section, and then all the optional sections. And I think they are adding more in the next release. SNOMED, which usually you have to pay for, created something called the GPS, which is a set of SNOMED free for use inside of the IPS. Tools that you can use. The first one is the IPS viewer. You can go there and see how an IPS is using the sample, or you can paste your IPS and see how it looks in the screen. Examples of IPS from John Damore site, and a tester for your IPS server from Inferno. And if you want to play with an open source reference server, you can use this server. This server is our HL7 server for IPS testing. And it uses something that was introduced in the last years, which was the dollar summary. Remember that dollar means operations, special operations. So I'm asking the server, for patient 63, give me the IPS. And it will create it on the fly, because that's something new in FHIR Happy from version 6.7. And if you want to really play with it, you can create your patient using a post, and then you can create conditions, allergies, and medication for this patient, and then you can ask the server for the summary, and it will give you your IPS. So I encourage you to play with this server. This is an open sandbox, so this information may not be here today, but you can create your own. How are we? Wrapping up. So this is about the GDHP and the support for IPS. And these are the organizations supporting IPS. And it's expanding. And then something around IPS is how do you give the patient something that will lead some clinician to the IPS, but I think Carl will talk about it. I will not talk about it. I will skip all this section then.
I can also say, or remind people, there is a IPS deep dive that we're going to have as a breakout session tomorrow.
Perfect.
So I think we can try to go into this in more depth.
And finally, a little words about the JIC. It's a group of standard development organizations because IPS is FHIR, but it's also a European standard and an ISO standard. So these organizations together will manage the future of IPS and how to handle modifications to it in the future. And I'm finished.
Thanks, Diego. Everyone, round of applause for Diego.